Hi friends, in this video we shall discuss about the fabrication of monolithic integrated circuits. In the previous video I gave an introduction on integrated circuits. So to know what an integrated circuit is, please watch my previous video. So fabrication of monolithic integrated circuits is nothing but forming an integrated circuit on the silicon wafer, and the chip is packed in a package, a plastic or ceramic or metal. From that package pins are drawn and it is connected to the external world. Okay, this is package you see in many electronic circuits. This type of packaging is called as dual in line package. So here we have this plastic cover, okay, which covers the chip, and this is the external pins through which the IC is connected to the external world. So this final package has to undergo all these processes before it is used in any circuit. So these are the various steps an integrated circuit goes through before it turns into a ice package like this. So silicon wafer preparation, epitaxial growth, oxidation, photolithography, diffusion, ion implantation, isolation technique, metallization, packaging are these various techniques. So now let us discuss these processes one by one. Once we cover all these processes, at the end we shall link them together. So now let me start with the first fabrication process, silicon wafer preparation. So silicon wafer preparation. So in silicon wafer preparation, as you know, wafer is the base of any integrated circuit. The the wafer is made of silicon. The silicon wafer preparation is a very difficult process, and it is not manufactured in most countries. Very few countries are manufacturing the silicon wafer. Okay, so other countries are buying those wafers. Okay, mainly the major producers of silicon wafers are China, US. These two are the major producers of silicon wafer. Okay, so the silicon wafer preparation starts with polycrystalline silicon. Polycrystalline silicon. So polycrystalline silicon is the purest form of silicon. Is the purest form of silicon. This polycrystalline silicon, let's say the purity is claimed in this manner, 99.99% pure. The purity of the silicon is somewhere close to 100. Okay, 99.98. This purity is which is controversial because companies used to claim that their polycrystalline silicon is uh, more pure than the others by adding the digits. Okay, so top companies claim that their silicon is very pure, so what they do is they keep adding the digits. They keep adding the digits to claim that theirs is very pure. So the polycrystalline silicon is heated to a very high temperature. The melting point, the melting point of this polycrystalline silicon is 1420 degrees Celsius. So this melting point of this polycrystalline silicon is 1420 degrees Celsius. So this is a crucible. This is a crucible on which I place the polycrystalline silicon. On which I place the polycrystalline silicon. This polycrystalline silicon is heated to a temperature greater than its melting point. So the temperature at which the polysilicon is heated is greater than its temperature, melting point. So you get a molten polycrystalline silicon. Polysilicon. So on which I am going to dip a seed crystal. Seed crystal is a small piece of polycrystalline silicon that is placed on a holder, and the holder is brought close to the molten polycrystalline silicon. When this seed crystal is dipped on the polycrystalline silicon, the molten silicon, when it touches the seed crystal, it solidifies. So what happens is, as you pull the holder up, as you pull the holder up, what happens is the molten silicon, which is solidified by the seed crystal, okay, mounts up. So as you pull it up, the solidified silicon mounts up. Okay, the size of the silicon, okay, that is mounted up on the molten silicon is decided by the rate at which I rotate the holder. Okay, so this holder is rotated. Okay, for here, for instance, if the holder is rotated in the anti-clockwise direction, okay, the crucible also rotated. The crucible is also rotated, which is rotated in the clockwise direction. So this is the one thing you have to note, that the holder is rotated in one direction and the crucible is rotated in the opposite direction. They are rotated at certain speed. The rate at which these two are rotated decides the size of the cylindrical wafer, okay, that is obtained by this pulling. The cylindrical bar of silicon that is obtained by this process is called as silicon ingot. So once the desired size is reached, okay, so we take that ingot out of this crucible and we cool it. So you get a cylindrical bar. You get a cylindrical bar. Then the cylindrical ingot is sliced. Okay, cylindrical ingot is sliced to thin wafers like this. So slicing is done by diamond coated steel wires. Okay, so these ingots are sliced as thin wafers. Typically the wafer thickness is 0.5 mm. Okay, so wafer is sliced by diamond coated steel wires. once the wafers, once sliced wafers are obtained, these sliced wafers are smoothened. Okay, these sliced wafers are smoothened. So these silicon wafers are smoothened at one end. Okay, one side. So smoothened at one side. Why it is smoothened at one side? Because one side of the wafer is only going to be used. One side of the wafer is going to be used for forming that integrated circuit. So other side is going to just act as a base. Okay. So this is a silicon wafer. So this is a silicon wafer. So only one side is smoothened and polished. Smoothened, smoothened and polished. Okay, smoothened and polished. So this is how this wafer is prepared. So one more thing I would like to add. Here we were talking about wafer preparation with the help of polycrystalline silicon. So the wafer you get through this process is a pure silicon wafer. If you want a p-type wafer or n-type wafer, you add impurities. You add n-type impurities if you want n-type wafer along with this polycrystalline silicon, or you add p-type impurities to get a p-type wafer. Okay, this is how we can get a p-type or n-type wafer. So this p-type and n-type wafer, this p-type and n-type wafer can be obtained. Okay, this p-type and n-type wafer, which is obtained by the silicon wafer, is differentiated by the marking. So usually what happens is when the when this ingot is manufactured, okay, when this ingot is manufactured, so this cylindrical one, so which is flattened, which is flattened. Okay, this is your ingot. So which is this a flattened part. This flattened part shows that this is a p-type wafer. Similarly, the silicon wafers are flattened, so the finer wafer would look like this. Okay, this part is flattened of the wafer, so to show that this is a p-type. So in some wafer it is flattened at 2 ends. It is flattened at 2 ends. So here there is a flattened part, here is another flattened part, to show that this is maybe n-type layer, this is a p-type layer. To differentiate the type of wafer, this flattening pattern is used. Okay, so by this I conclude my discussion on silicon wafer preparation. In the next video I will try to cover the rest of the processes. Okay. So as I told, I am going to post videos on integrated circuits. Okay, I'm going to post videos. So if you want to watch more videos on integrated circuits, so you will get notified if you subscribe my channel. Okay, so please subscribe my channel so that you will be keep updated with the videos I post, so that you can watch my videos oftenly.